don't get concerned about the form your hydrogen ion concentrations take. For example, if it says your hydrogen ion, or they might even say like HCl, tell you about hydrochloric acid, and they're giving you this concentration of molarity, just use that number. So the pH is still the negative log of the hydrogen ion concentration, okay? You can enter it as 0.004. So if you take the negative log of 0.004, enter, okay, you're going to get 2.397 or 2.4 as your pH, okay? Another thing you're going to be doing is you're going to be completing this chart. Let's say you're starting with a hydrogen ion of 1 times 10 to the negative fifth. What we're doing here is using all those relationships. Let me put those up here. We're using all these relationships to complete this chart. First, pH is the negative log of the hydrogen ion concentration. Okay, hydrogen ion is second log negative pH. Okay, POH is the negative log of the hydroxide ion concentration. We can also get the hydroxide ion concentration by taking the second log, the negative POH. Let me just put that negative POH. We can also know that POH and pH equals a total of 14. So here's what we're going to be doing, okay? And okay, one more. And Kw, 1 times 10 to the negative 14 equals the hydrogen ion concentration times the hydroxide ion concentration. So we have all those relationships. That's what we're doing with this chart. Let's say you're given the hydrogen ion concentration is 1 times 10 to the negative fifth, okay? To do the pH, you do to the pH negative log of the concentration. So you do negative log 1 exponent negative 5, enter. The pH is 5. Okay, I know that hydrogen times hydroxide is 1 times 10 to the negative 14th. That means 1 times 10 to the negative 14th divided by the hydrogen ion concentration, 1 times 10 to the negative 5th, is hydroxide. So what I do is I take Kw, 1 exponent negative 14, divided by 1 exponent negative 5, hit enter, and the concentration is 1 times 10 to the negative 9th for the hydroxide ion. Now, there's a couple ways I can do this. I can take, to get POH, I can do 14 minus 5, which is 9, okay? Or I can do POH is the negative log of the hydroxide ion, okay? So I can do negative log of the hydroxide ion, 1 second exponent negative 9, enter, is 9. So there's 2 different ways. Now what if you're given the pH? What if you're given a pH of 4, okay? We can work backwards and get the hydrogen ion concentration, okay? If we have pH and we want hydrogen, okay, I take second log of the pH, or the inverse log function. So I do second log negative 4, enter, and my concentration is 1 times 10 to the negative 4th. Okay? Now, I know that hydrogen times hydroxide is Kw, 1 times 10 to the negative 14th. That means 1 times 10 to the negative 14th divided by 1 times 10 to the negative 4th will give me hydroxide. Let's do that on the calculator. Okay? So I do 1 exponent, okay, negative 14 divided by 1 exponent, negative 4, enter. I'm going to get 1 times 10 to the negative 10th. Okay. Last thing I need is hydroxide. Okay. The POH and the pH is 14. So 14 minus the pH, 14 minus the pH of 4 is going to be 10. The other way I can do it is POH is also the negative log of the hydroxide ion concentration, okay? So I can do negative log of 1 second exponent, negative 10, enter, and get 10 that way. So you're going to have a data chart on one of your papers, and what you're going to do is you're going to use the same deductive reasoning. We have the relationships. Let me go through those relationships again in a second. We have the relationships, and you're given different pieces of information. You're applying these relationships to solve for what are the hydrogen, hydroxide, pH, and POH. So let me go through that one more time. So your pH is your negative log of hydrogen ion concentration. POH, it's used, it's just not used much, is the negative log of the hydroxide ion concentration, okay? And if we know the pH and we want the hydrogen, we work backwards. The hydrogen ion concentration is the inverse log. Usually it's shift log or second log of negative pH. Same is true if we want the hydroxide ion concentration. It's the second log or the shift log or the inverse log of negative POH. Now, we also know POH and pH equals 14. And KW, it's actually an equilibrium constant for water, and hold that thought, is 1 times 10 to the negative 14. The KW equals the hydrogen ion concentration times the hydroxide ion concentration. And you're going to be given one of these 4 pieces of information, and you're going to work backwards in order to complete the chart, just like we did here. All right?